All right, guys. Hello. In this video, we are going to talk about a little bit more of an extension of the 4.3 section that we had. Just because I've noticed in class we were having a hard time understanding the period of a function and really how all of that works. So we need to kind of dial it back just a second, and then we'll take the trig out of it for just a minute, and then we'll kind of bring trig back in. Okay. So here with this. Again, this is just an extension of the 4.3 idea, so we can practice the periodic nature of some functions. So if a function is periodic, what it means is that it will have this like cyclical nature. So it's going to cycle through a pattern, and it's going to do it repeatedly for always. So that pattern and the length of your x values that it takes to complete that pattern, that's what we call the period. So if you looked at this function right here, you can see that it goes up, over, down, and then it repeats that. But it takes 4 units to complete that whole pattern before it starts the cycle all over again. So on this, I would say like the period of this function was 4, because that's how long it takes to repeat the pattern. Okay, so if you look at example 1, they said that we're going to look at this graph up here, and they want us to draw 2 additional periods. So all we're going to do is just draw this same pattern 2 more times. So we know this is going to go up. I'm going at the same slant that I was before. This was to the right, 2, up, 2. So I'm going to follow that same slope. Then we're going to go over and then down, and this was a steeper slant. So just make sure that you're following the same pattern that the other one was. You go up, over, and then down again. And that was our 2 more periods. We got those drawn. All right, let's take this down to another problem. So this one right here that says we've got a portion of the graph of a periodic function is shown. What is the possible or the least possible value for the period? Typically, we would just say, what's the period of the function? But I think they're just trying to make sure that you don't count from the far left to the far right. They're wanting you to make sure that you're only getting the smallest possible value for this pattern. What you can typically do is just find a point on the graph that's kind of noticeable and just count the units between them. So like a lot of people look at this guy and they're saying, okay, well, from here to here, that's kind of a good indicator as to when the pattern starts over. So you could definitely count from there to there. You could count from the y-axis over to here. It doesn't really matter as long as you are making sure that you cover the whole cycle, that whole period between there. So just find some defining points to follow. Now, if I count between this point and this point on my x-axis, that was 4 units. No, not 4. I'm lying to you. 5. I was thinking of the last problem again. But this is 1, 2, 3, 4, 5. The period on this one is 5. All right. Let's take that same problem, but then actually do something else with it. So on example 3, they said we're going to use that function, that same one that you're seeing up there, and find the following values. They want us to figure out what is g of 14. Now, in the past, when we've asked for this kind of thing, we were just able to take 14 and plug it into a function and get an answer. Or you were able to look at a table and get your answer. Or you could look at the graph and you could find your answer. But the issue here is 14 is not on my x-axis. Now, some people will say, well, let's just draw a few more lines over here and then continue the pattern, see where this lands. But you can do that. The problem is that on B, when I'm supposed to draw 72, I don't want to draw 72 on my x-axis and draw that pattern out. So we need to find a more efficient way to do it. And so that's what I'm going to show you here. So just bear with me for a second. You'll understand the reason of my madness in a second. But we're going to rewrite this. Let's manipulate the function, okay? Instead of writing g of 14, okay, I'm going to rewrite this. I'm going to break it apart. Okay, I want you to go through the math here. Do you agree that this is the same as g of 14? 2 times 5 is 10, plus 4, yes, 14. So I didn't change the value. We're just changing the way this looks. But in doing this, I know you're like, why on earth did you do that? In doing this, we're able to see an easier way to solve the problem. Remember that here we said that the period was 5. And every time a period goes by, it's repeating itself. So technically, we should be able to predict this value because the same values come out over and over and over with the graph being periodic. If it repeats itself over and over and over, the values in the function will repeat themselves. Technically, what I'm seeing right here is that 2 periods have gone by, right? The way that I wrote this is showing 2 periods have gone by. Remember, a period was 5 on this problem. So 2 periods go by. And remember, since the values repeat themselves over and over and over, then G of 4 is actually going to be the exact same thing as what G of 14 would have been because those values are repetitive. I can find G of 4. All I got to do is go to 4 on my graph and then follow it up. The output is 7. And there's that answer. Let's look at B. Like I said, I don't want to have to draw out 72. So this is this is a good use of our little strategy here, breaking apart this function. We're going to see if we can rewrite this. Now remember that the period is 5. That makes it a little easier because it's an easy number to work with. But what I could do here is maybe think of like 2 plus 14 times 5. 14 times 5 is 70 plus 2, 72. So I haven't changed the value. But this is just showing that 14 periods go by. 14 periods. So I actually don't really need that part because, again, it's just repeating itself over and over and over. This is just showing that it's repeated over 14 times. G of 2 should be the exact same thing as G of 72. So if I go here and I look at 2, I follow that up, my output was 6. Last one, it's a little bit trickier when they're negative like this. So we're going to have to try to figure out a way. There's actually a couple different ways. So if you want to pause the video and try it, feel free to try it. We should all get the same answer in the end regardless. So as long as you do it right, we should get the same answer. I have seen 2 different ways. What some people have told me is they said to take rewrite this as a -2 minus 3 times 5. You're going to have to subtract your period regardless because you're coming out with a negative number. So some people have told me -2 minus 3 times 5. That works. Another one, I'm going to write this one out. If I do 3 minus 4 times 5. Some people find that one easier to work with. Either one is fine. This is the one that I did originally. But again, this is just saying that 4 periods go by. 3 minus 20 is -17. So this is the same output, just 4 periods have gone by. And I just need to look for G of 3 then. G of 3, go here on your graph where X is 3, my Y is 7. All right. So what if we take the graph away? Can we deal with it if we take the graph away? All right, next page. Instead of using a graph on this one, I'm going to use a table. So using a table should allow me to still do the same type of thing. I just am a little bit more limited on this. So I want to bring back this other one really quick just to show you. If you remember on this one over here, when we were trying to find our ways to rewrite the numbers, I could really, I had so many options. I could have gone from -2 out to 9 and been able to use any number in there to help me rewrite the function. But the problem is here, we're a little bit more limited because we only have 4 values instead of all those other ones. So what we got to do is we're limited there. And for some people, that actually helps, but not everybody. It just depends on you. What I'm going to do, knowing that this is a period of 5, what I'm going to do here is I'm going to pick a number from the table, okay? And we're going to specifically pick one where if I were to add or subtract the period or a multiple of it, we would get this -2. So I'm looking through here. My period is 5. If I were to add I think immediately my brain says you're going to have to subtract because all of these numbers are positive. So I'm thinking let's subtract 5 from each of them. 1 minus 5. Nope, that's not -2. 3 minus 5. Hey, that is. So if I did 3 minus, and we just subtract ourselves 1 period for this function, that is the same thing as h of -2. But again, since this is 1 period, right, then really all I need to do is do h of 3. And h of 3 is in my table, 0. All right, let's do h of 6. Again, you're going to have to either add or subtract your periods or a multiple of it. So I'm looking through here, 6. If I start with the number 1 and I added 5, that would give me 6. So let's say I'm going to write this as 1 plus a period. 1 plus 5 is in fact 6, so we're good there. I don't need to rewrite this period because again, the values are just repeating themselves over and over. I just need h of 1. And h of 1 is -2. All right, C, you might be looking at this one and thinking, what is going on there? Is there a typo? There is no typo. This is saying h of 9. So I need to figure out what is h of 9 to begin with. That's my first thing. So if I can find h of 9, then we'll kind of be good to get started here. I don't have that in the table, but we could figure it out. So if I do, let's pick a number, see if we can find something to add or subtract 5 with. So 1 plus 5, 6. Nope, that's not 9. 3 plus 5 is 8. Nope, it's not 5. 4 plus 5. Ah, there we go. 4 plus a period. So really, I just need h of 4 because it would be the same thing as h of 9. H of 4 from my table is 3. Now, this is not my final thing because I'm supposed to be finding h of 9. I know h of 9 is 3. So now I need to plug that in. We're going to say plug that in place of the h of 9. So this is really just going to be h of 3. And that is in my table. H of 3 is 0. All right, this guy, we're going to say, I know this looks a little scary, but I want you to keep in mind what we've been doing this whole time. We've been rewriting this stuff so that we could show how many periods have gone by. And the way we've done that is we've been taking a number times the period, right? Our period here was 5. So back here, if I did 1 times 5, that was 1 period that had gone by. Now I want you to look at this guy. It might help if I rearrange it. I don't know if that makes it easier for you or not. But really, what I'm seeing here, when I see 5 times k, it's the same kind of thing as when I saw 1 times 5 over here. If 1 times 5 showed that 1 period went by, k times 5 shows that k periods have gone by. And as long as a full period has gone by, it doesn't actually matter how many of them there actually are, because you're going to end up at the same value anyways. So really, I just need to figure out what is h of 3. The k part is actually not necessary to get my final answer. It was just necessary for me to see that full periods had gone by. All right, so let's see what we can do here. Now, -3 is not in my table, so now we're going to have to do the thing where we rewrite this. I've got to find, are there any of these values where if I subtract 5 or a multiple of it, I'd end up with a -3? Let's see, if I were to subtract 5 from any of these, I'm not getting a -3, but what if I subtracted 2 times 5? I'm thinking that if I were to do, let's say, I bet you we could do this. Let's see if we could do 7. Ah, there we go. 7 minus 2 times 5. Yeah? 7 minus 10, negative 3. So h of 7 is what we need. The answer would be 2. All right. Last little bit, guys. We have one more example to do, but I need to explain something first. Just an idea, kind of a concept. So periodic functions. I'm going to bring this back from earlier. Okay, so here we go. This is what we had earlier at the very beginning of the video. Periodic functions are repetitive, right? So what I want you to think about is what would happen if I translated this to the left or translated it to the right. If I translated it the full period, right? This was a period of 4. If I translated this 4 periods to the left, imagine what this would look like. It would look exactly the same. Or what if I took this and I shifted it 4 units to the right? Same thing. It's going to look exactly the same because everything's in the same placement. Now, if I were to shift it a different number, like maybe 2 or 3, if I only shift it a little bit, not a whole period, then it's not going to look exactly the same. You don't get the exact same outputs and inputs. So you got to keep that in mind. But if you were to shift it a whole period, it does map back onto itself. So there's like a little extra bit of notation that we can use because every periodic function can be seen as a horizontal translation of itself. You can see them just translate back onto themselves. Okay, with that being said, thinking about the function we had up here with the table, right? The period was 5. Well, in that case, whatever the original function was, h of x, that should be the exact same thing as if I shifted this to the right 5. H of x minus 5, because the period was 5, all the values would be the exact same at that as they were at h of x. So, okay, cool. Then, here we go. Yeah, one more example to go through, and then we are done with this video. So example 5, it says the graph of f is periodic with a domain of all real numbers. That is an important feature because it doesn't look like all real numbers on your graph. So you can't just assume things. You got to make sure you read everything. And since they say that the domain is all real numbers, we have to keep in mind that this is supposed to continue this pattern forever and always on both sides. It says that 2 full periods are shown. Find the input values of f that yield an output of 1. So we're supposed to be finding all the x's that give a y of 1, right? So I'm looking for output 1. Well, all the places I see here at 2 and I see here at 6. However, that is not all of it. So you can't just list 2 and 6 because of this guy. Because the domain is all real numbers, we know that this pattern is continuing forever and always on both sides. So there's an infinite number of solutions and an infinite number of answers, but I can't, it's not just 2 and 6. I also can't say negative infinity to infinity because it's not every value. It's like only at little intervals of 4. If you add 4, you get to the next one. Add 4, you get to the next one. So what we're going to do, since this period here, to be able to repeat itself, is 4, we're going to use that to write an expression. Okay? Now, there are technically different answers I could give for this, but I would say probably it's just going to be easier. Figure out what is the first value, what is the first x to yield an output of 1 that I see. That's 2. So I'm going to start there with 2. And what we're going to do is we're going to add intervals of 4. So I'm going to say add 4, and let's say times k. K is going to just talk about the number of periods because this thing goes on for forever. But this would indicate all of the different values where we get a 1 as our output instead of just the 2 and the 6. Now, I would be good with you saying 2 plus 4k, 2 minus 4k, 6 plus 4k, or 6 minus 4k. Any of those would have been fine answers. All right, now I told you I'm not going to do another example, but I do want to go ahead and forewarn you guys because we are at the point where we're going to start doing a little bit more of this AP exam prep for my AP classes. So if you are in the AP Precalculus, I encourage you to watch the next video so that you can get help on how to do a problem like this guy. It's like a free response question, similar to how it will look in the AP test. So if you are on level, don't stress about this. You can skip it. If you are taking the AP test, though, I do encourage you to check this out. It will be a separate video posted shortly after this one. Okay, so I will see you guys in the next one, and good luck. Bye.